Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on EMC consideration. Okay, so for this video, I'm going to concentrate on conductor emission. Okay, in fact, I have a series of questions on conductor emission. So basically, this video, I'm going to answer some of the questions on conductor emission. Okay, based on CISPR 11, CISPR 25. I'm also going to do a quick discussion, the key difference between IEC 61000-6-3 and 61000-6-4. I'm going to explain the key difference between these two. And last but not least, on FCC Part 15 test standard. Okay, so this will be the Part 61 series discussion on EMC. So guys, if you're keen to know more about EMC, okay, please take a look on the playlist, okay, under the description. Over there, you will be able to find a series of discussion on EMC. This is my email. Okay, if you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask your question through the comment. Okay, also maybe suggest some of the key topics that you guys are keen. Okay, so before I continue, I'd like to urge you guys to help this channel by like this video. Okay, please click the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for your strong support. Before we do anything, we always like to question, okay, why we need to do this. So for this case here, we also need to know why we need to test for conductor emission. Okay, so conductor emission, they in fact are very crucial, okay, to ensure the electromagnetic of any electronic device. Okay, so these are four key reasons, okay, why we need to test for conductor emission. Okay, the first one is we need to prevent any interference. Okay, I guess you know the severe of interference. Okay, basically the interference may change the outcome, may cause an issue that you are not able to receive any signal, etc. Okay, so therefore, okay, the first key thing of conductor emission is we need to ensure that we don't generate signal that cause interference to others. So what is actually this prevent interference? Conductor emission are noise components generated by a device that can travel through power and signal line to other device. So in short, conductor emission happen on the cable. Okay, for example, if you have a device that generate noise, okay, for example, it can couple over the air onto the cable. This is still called conductor emission. If not, the noise generated by the device travel along the power line or the signal line. Again, this also can be classified as conductor emission. Okay, if this is not controlled, okay, this emission can cause interference, hence affecting the performance of other electronic equipment. Okay, you can imagine that basically the power supply, let's say, is shared by different device, and basically one source noise basically affect the other device that connect to the same power source. So hence we need to ensure that we do not create any interference that basically so-called affect the performance of other electronic equipment. Next, okay, regulatory compliance. Okay, many countries have strict regulation, okay, regards on EMC. Okay, so basically you can see that Europe has their own EMC. FCC, which is by US, also have their own EMC. In fact, besides that, Japan, China, etc., all these companies, all these countries have strict regulation regards on EMC. Okay, the device, okay, if you want to sell this device in that particular country, you need to ensure that they actually pass the conductor emission test, okay, before you can actually start to sell the product in the market. Okay, so this test ensure that the noise level are within acceptable limits, okay, prevent potential disruption to the power grid and other connected device, okay, as I explained earlier on also. Okay, number three, okay, we need to ensure that we maintain the power quality. Okay, so let's say if we have high level of conductor emission, okay, hence this may potentially degrade the quality of power supply to device, okay, leading to issues such as flickering light, poor performance of appliance, and even damage to sensitive equipment. So in short, okay, let's say your emission actually can cause severe, okay, so-called effect on the neighboring device. Okay, as such, the first EMC test is the first EMC standard is because of this flickering light. Okay, so basically you realize that the light start to flicker. Okay, so and also some poor performance. Okay, so in a household we have a lot of appliances, and because of one, okay, source of noise, for example, when you actually turn on your heater, for example, okay, the heater actually can create some disturbance on your TV, and you actually start to see lines appear on the TV screen. So this is one of the key things that we need to ensure the power quality. Next, okay, we need to ensure the device reliability. Okay, by controlling conductor emission, okay, manufacturer can ensure that their device operate reliability, okay, in various environments, okay, without causing or being affected by electromagnetic interference. Next, okay, let's quickly understand, okay, what are conductor emission? Electromagnetic energy that is coupled into power lines or associated circuit is considered conductor emission, which I have explained. So CE can be classified as either common mode interference or differential mode interference. So there are actually two types, either common mode or differential mode. Common mode interference actually appeared in the live wire. Okay, for example, over here you can see the common actually in blue. So basically they can be appeared in the live or the neutral. Okay, as you can see from here, it can appear at the live wire, neutral wire, or maybe also the signal wire. Okay, with respect to earth connection. Okay, which means that the noise over here, for example, which is the live, with respect to the earth. Let's say if you have a signaling cable, okay, the noise at the signaling cable with respect to the earth, all these are called the common mode interference. Okay, it is often affect signal and control lines and is typically associated with high frequency switching. Okay, so the next one will be differential mode interference. Basically, they occur between the live wire and neutral wire or between signal wire. Okay, is result from low frequency switching. Okay, as for differential will be the red arrow. Basically, you can see that for differential, they basically form a loop. Can you see here? So basically, this is actually is so-called between the live wire and neutral wire. For example, for this case here, between the live wire and the neutral wire, basically they actually form this differential mode interference. Okay, so next, okay, so this diagram shows a typical conductor emission test setup, okay, which is according to the ANSI C63.4 standard. Okay, so basically the key thing is I want to quickly mention this because I realized that I have not mentioned this in my early on so-called discussion. Okay, the listen, okay, they can sit on the ground. So for example, the listen, okay, they can be on the ground while your product can actually sit on a table. Okay, so basically this is a non-conductive table. Okay, your DUT can be actually on the table. Okay, but if not, if let's say your DUT is too huge, too heavy, then it can be remain floor standing. Okay, which means that you can also put your DUT on the floor. Okay, the RF port of the listen actually connect directly to spectrum analyzer. Okay, remember, okay, at the listen, you actually has a so-called the output, okay, from the listen. Basically, this part here basically will be connected by a so-called RF cable. Okay, let's say the N type cable basically will be connected to the spectrum analyzer, okay, or via a transient limiter. Okay, so basically this transient limiter actually suppress or attenuate the signal. Okay, so this is to prevent any damage from voltage spike. Okay, in case that there will be a big spike, okay, this transient limiter will so-called attenuate or minimize, okay, the damage. Okay, so let's quickly understand, okay, about conductor emission applicability. Okay, conductor emission testing is typically performed on device that connected to an AC power supply. Okay, regardless of whether a pre-certified AC/DC power supply adapter is used. Okay, so in short, okay, let's say your device require a AC source, then you need to do this conductor emission. Let's say, for example, if your device are all battery powered, then you may not need to do any conductor emission. Okay, so in short, okay, basically, if you have any product that require AC power supply, then it's a must to do conductor emission. However, if there is no cable to charge the device that you actually make, for example, there's no USB cable to charge your device, no power, AC power, then you may consider so-called skip the conductor emission test. Okay, for certain standard, limit are also imposed on device that operating for a DC power supply. In short, for example, some sensor, okay, basically they actually all operate in a DC. Then, okay, basically there will be some standard that actually constrain the testing of this sensor, okay, from a DC power supply. Okay, so what are the standard for conductor emission? Okay, so any electromagnetic disturbance, okay, basically the regulatory commission actually issues standard to limit conductor emission. Okay, so this standard vary by products category and depend on the electromagnetic environment where the product will be used. Okay, for example, SCC, which is the US, okay, the SCC standard address conductor emission in the 450 kilohertz to 30 megahertz frequency range. Okay, while the CISPR 22 standard limit conductor interference in the 150 kilohertz to 30 megahertz. In short, you can see over here, Europe is much more stringent, okay, because the test start at 150, while America or FCC standard actually start at 450, okay, and both have the upper so-called cutoff frequency, which is at 30 megahertz. Okay, to ensure compliance with this standard, emission testing is conducted. So in order to ensure that we actually comply to the conductor emission, okay, so basically we need to do this test, okay, from either 450 kilohertz to 30 megahertz or 150 kilohertz to 30 megahertz, depend where you actually want to sell this product. Okay, so this page here quickly show, okay, over here on the left hand side, you can see that these are all the different products. Okay, so basically this explain what are the type of equipment that you're actually testing. So with this, you actually can test according to the CISPR standard, okay, or the FCC standard. Okay, some case here where the application is mainly for military, then you probably need to consider to use the mil spec standard. Okay, so which is the mil standard 461G. Okay, so in short, okay, based on the different product, okay, again, you can refer to the different test standard, okay, before so-called whether your test is at Europe or USA. Okay, let's go through some of the so-called test standard. Okay, for this page here, we'll be going through the CISPR 11. Okay, CISPR 11 is a standard that developed by the CISPR. Okay, they mainly deal with the electromagnetic compatibility of industry, scientific, and medical ISM radio frequency equipment. Okay, for example, you build a product, okay, they basically will be transmit, okay, in the unlicensed band, which is the ISM band. Then you can use this CISPR 11 to perform the test and measurement, okay, on the conductor emission. Okay, so this standard specified the limit of emission from equipment in the frequency range of 9 kilohertz to 30 megahertz. Okay, using a conductor measurement technique on the AC main supply cable. Okay, so basically, in short, okay, basically we are going to measure, okay, the emission from the AC main supply cables. Okay, the conductor emission limit established by this standard are intended to protect equipment connected to the same AC main supplies and are also assumed to safeguard the radio communication spectrum below 30 megahertz from the field radiated by the equipment AC supply cable. Okay, so in short, okay, basically if you build, for example, a mobile phone, okay, with Bluetooth, okay, then you need to test under this CISPR 11 standard. Okay, so over here you can see that under CISPR 11, you have Class A and Class B, which is the industry for Class A and resident for Class B. And we also have this Group 1 and Group 2. Okay, so basically for Group 1, okay, will be all other ISM. Okay, let's take a look on Group 2 is basically ISM band with intention radiate. So for example, you build a mobile phone. Okay, they basically have the intent to radiate. So basically this case we put under Group 2, while the rest we can actually lump them under Group 1. Okay, so again, these are all the various limit line. Okay, so for the CISPR 11. Okay, so mainly for the main port, which means that the AC main. Okay, for this case here. In short, over here, let me quickly let you understand this. Firstly, you look at whether is it for Class A or Class B. So if you still remember, for Class A and Class B will be Class A for industry and Class B for resident. So for example, if it's for Class B, then everything will be so-called test according to this limit line. If let's say it's Class A, then either one. So if your test, okay, is basically for industry, okay, which means that for Class A, so either one, then you need to look at your power source. Is it more than 75? Is it more than 20? Okay, so basically after this, basically if it's lower than 20, then you will fall back over here. So in short, okay, whether your Class A or Class B, firstly look at the different class, and then after that you look at the power, and then basically you decide which limit line will be the best use. Okay, so this is for the CISPR 11. Okay, again, this is also for the CISPR 11. Okay, earlier on, mainly is for the main port, which is the AC. Okay, for this case here, this is for the DC. Okay, how to test? Basically, all the lines come with the explanation. Okay, I won't be able to go through in deep detail. Okay, but over here, you can see that, okay, basically, quasi-peak limit line, average limit line, and then basically from here, you can determine whether you pass or fail the test. Next will be on CISPR 25. Okay, so this standard set limit for measuring radio disturbance in onboard receiver caused by vehicle. Okay, so basically beside vehicle, we also by boat and internal combustion engine, trailer and device within the frequency range of 150 kilohertz to 1 gigahertz. Okay, so in short, this is basically include the radiate emission also. Okay, so beside conductor emission, this also include the radiate emission. Okay, the limit are designed to protect onboard receiver installed, okay, according to the manufacturer guideline in a vehicle from conductor disturbance produced by component modules within the same vehicle. So over here you can see that, okay, basically we will be test in the long wave, medium wave, and also the short wave. Okay, the rest, okay, basically will not fall under conductor emission. Mainly will be radiate emission. But in short, okay, basically we need to focus on the long wave, medium wave, and short wave. What are all these, which I will explain on the next slides. Okay, so basically this is the limit line, okay, as you can see from here. Okay, so the limit for disturbance may vary. Okay, actually it depends on the source. Okay, long duration disturbance source, such as a heater blower motor, okay, must meet stricter requirement than short duration disturbance source. So in short, for example, in a vehicle, you actually turn on, for example, a heater blower motor or aircon. Okay, basically then they need to have a stricter equipment, because most of the time this so-called this blower will be on, okay, rather than some of the short duration, okay, source. Basically, let's take a look on the next slide to understand better. Okay, the vehicle manufacturer can determine the acceptable level for short duration source. Okay, for example, door mirror operation. Okay, for example, okay, we want to stir up or stir down the door mirror. Okay, basically this only use in terms of the very short time. So hence, okay, you don't need to be very stringent on this. Okay, so might be allowed to have a higher level of disturbance, okay, since it's only operate for 1 or 2 seconds at a time. So in short, okay, basically over here you can see that for the vehicle standard, okay, those that need to be utilized for a long time, okay, for example, aircon, heater blower, then you need to be stricter. Okay, for those that only just for 1 second or 2 seconds. Okay, as for this slide mentioned is a door mirror, then we can be a little bit relaxed on this criteria. Okay, so quickly explain the IEC 61000-6-3 and -6-4. What will be the key difference? In short, okay, so basically this is a generic standard that specifies the emission test requirement, okay, that is covered by this scope addressing continuous and transient conductor and radiate disturbance. In short, this test here so-called has a comprehensive test and measurement. Okay, the emission limit are set to ensure that the disturbance generated by the appliance basically operating normally in resident, commercial, and light industry environment. In short, for this -6-3, okay, typically for resident, okay, or commercial, basically the building where we are, okay, whether is it where we live or where we work, okay, minus away the industry. Okay, so basically commercial, which means that not so much heavy industry, just a commercial, simple, let's say office, etc., will be fall under this commercial. And light industry environment, that do not exceed limit that could interference with the proper operation of other equipment. Okay, so as for dash 6-4, mainly is for industry environment. Okay, so I guess you will be able to read this, but in short, dash 6-3 mainly for resident, dash 6-4 mainly for industry. Okay, so basically in short, this is the key difference between these two. Okay, the FCC Part 15 conducted emission limit line, okay, for Class A and Class B are set differently. Okay, you can see that Class B, okay, typically for domestic environment, they are stricter. Okay, so this is slightly because households are expected to have many devices, and hence it is very important, okay, to ensure that this device don't interfere with each other through conducted noise on the AC power supply. In short, okay, because in our house, okay, we have lots of appliances, and because of this, we need to ensure that they don't actually interfere with each other. And hence, because of this, okay, those so-called resident or those that under our household, okay, typically they will fall under Class B, which has a harsher limit line as compared to Class A. Okay, so with this, I'd like to end my discussion. Okay, please help to like and subscribe. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you.